All right, welcome back to the last lesson. Last part of this lesson here. So I didn't want to rush through it because this one is a little bit different than the one above. So it says that the number of bacteria triples every 6 hours. So this is giving us two pieces of information. First one, it's giving us our base. It triples. So tripling is our base, our B value. And 6 hours is going to be our time factor, all right, in the exponent. So we've got two pieces of information in those, 4 words basically. It says 5 bacteria were present on the plate. So 5 bacteria, that's our starting value, the number of bacteria that we have. So it says under Alex's bed at 6 p.m. answer the following. So we want to know how much bacteria accumulates here while Alex keeps the plate underneath the bed. So a little bit of, yeah. All right, so A part. Determine an equation. So we know that our base equation is AB to the exponent x. We've deciphered some of the information already. We know our A value is 5. We're starting with 5 bacteria cells. And our base is 3 in this case. It's not a percentage. Okay, it's a factor of 3. It's tripling each time. So we're multiplying by 3. Our exponent is x to the exponent to the exponent x, and we're dividing it by 6. And again, that is because of every 6 hours. So every time that tripling factor is occurring every 6 hours. So there is our equation, y equals 5 times 3 to the exponent x over 6. All right, B part. So with B part, it says determine how many bacteria are present in the morning at 7 a.m. So Alex put the plate under the bed, again, U, at 6 p.m. to 7 a.m. So 6 p.m. to 7 a.m., that's a total of 13 hours. So that means that our formula will be y equals 5, bracket 3, to the exponent 13 divided by 6, okay? Because 6 again tells us how many tripling periods occurred in the 13-hour span. Now you need to use your calculator here, and again I'll slip over to the calculator, and again that exponent's going to be the trickiest part. If you're using a script calculator, you just write it in as it looks, but for the rest, if you're using a regular calculator, it'll be 5 times your base, and then you need to use your exponent button. Again, you're using the x to the y button found on your calculator, and again I have to put it in brackets because it's a fraction. So it'll be 13 hours divided by the tripling period of 6. Close that bracket. And that gives me a total of 54 bacteria in the 13 hours. All right, so 54 bacteria will be our answer. So therefore, 54 bacteria at 7 a.m. Really nice. Okay, C part. So, I'm going to move my page a little bit, hopefully successfully, not bad. Alright, so C part. Determine how many bacteria are present in 1 week. Alright, when Alex finally takes the dish to the kitchen. Yeah, like this is a total ew job altogether. So, we need to figure out in 1 week how many hours there are because we have set up our equation in terms of hours. So 1 week will give us, so multiply it, 7 days times 24 hours. So we're going to do 7 times our 24. So that will give us an 8, 14, 168 hours. I think that seems about right. So that means our formula will be y equals 5, base of 3, 168 divided by 6. And that's what we'll plug into our calculators. So clear that. 5 times 3 exponent bracket 168 divided by 6 bracket. So there are going to be a ridiculous amount. So if you count that, that's, what do we got here? Where's my pointer? So there's thousands, millions, billions, trillions. So here's a major yuck factor for you. So 114 trillion bacteria. I'm not even going to bother writing out that large of number. I'm just going to go 114 trillion, but I mean, most calculators will put that in scientific notation. So a lot of calculators will do this. So 1.14 times 10, and just go back to that for a second. So it's going to go groups of 3. So 3, 6, 9, 12, 13, 14. So with your calculator, if you have a regular calculator, it's going to have 1.14 times 10 to the 14 is what it's going to show up as. All right. So 114 trillion. All right. 114 trillion. So you can see why putting a plate under your bed not recommended, and that's why things become green over time. So a bit of a life lesson here: when you don't put dishes in the sink or dishwasher like you should, as they turn green, the number of bacteria become large enough that it becomes green and black, which is not healthy. So the next time you stuff a dish under your bed or don't take it to the dishwasher, you just think of this example and think about why things turn green. So anyway, there we go. There is properties of exponentials. Okay. So again, you are responsible for those 5 properties we talked about. The examples, I believe, or the homework assignment is simply those types of questions right there, and those questions right here will help you. Anytime you need to, you can put this into a graphing calculator at any point in time. If you have to read a value off the graph, that's also a possibility as well. So anyway, good luck. If you have any questions, let me know.